All right, today we're diving into one of the most powerful and frankly bizarre ideas in all of science. We're talking about a concept so strange that the genius who came up with it spent years, publicly insisting it couldn't possibly be real.
So, let's start with a really mind-bending question. What if the gravity that's holding you in your chair right now isn't some invisible force pulling you down, but is actually the very shape of reality, the fabric of the universe itself, pushing down on you?
Okay, to really get our heads around that, we've got to go back and look at Einstein's incredible radical vision of a warped universe. I mean, this was an idea that completely flipped centuries of physics on its head. You see, for hundreds of years, everybody just went along with Newton's idea of gravity. It was this mysterious, invisible force that just pulls things together. Simple enough, right? But Einstein comes along and proposes something way more elegant, and honestly, way weirder. He said there is no pull. Gravity? It's just the curvature of reality itself.
He had a name for this stuff, spacetime. It's this absolute four-dimensional fabric that weaves space and time together. And here's the cool part. Massive things, like planets and stars, they actually warp this fabric. Just imagine putting a heavy bowling ball on a trampoline. See how it creates that deep curve? That's kind of what mass does to spacetime. And that curvature, well, that's what we experience as gravity.
I mean, what a revolutionary idea, right? But it makes sense when you realize it came from a mind that just loved to question authority. There's this great story about one of his professors who complained, "You are a smart boy, but you have one great fault. You do not let yourself be told anything." And thank goodness for that.
And here's the great irony. The ultimate revolutionary, he would soon become the new authority figure. And in a wild twist, he'd end up rejecting the most extreme, the most monstrous prediction that came out of his own brilliant theory.
See, hiding deep within the math of his beautiful, curved spacetime, his equations were pointing to something absolutely terrifying. They predicted an object with a gravitational pull so powerful, so immense, that the curvature of spacetime literally becomes infinite, a cosmic dead end, a point of no return where nothing, not even light itself, could ever escape.
And Einstein, he hated this idea. I mean, he despised it. To him, it wasn't just messy or ugly, it was an attack on the very idea of a rational, orderly universe. An infinity in the equations, that's a place where physics just stops working, and he just couldn't accept it. He was so convinced it was wrong that in 1939, he actually published a paper trying to prove it was just a mathematical fantasy. He wrote that he had, and I quote, "a clear understanding as to why the Schwarzschild singularities do not exist in physical reality."
But here's the thing. While Einstein was busy rejecting this dark corner of his own theory, astronomers were out there pointing their telescopes at the sky, and they were finding things that just seemed to defy all known physics. So jump forward to the 1960s. We've got these powerful new telescopes, and they start picking up these things, super bright, super distant objects that they called quasars. And these things were a massive cosmic puzzle, because for the life of them, nobody could figure out how they could be so powerful. Okay, get this. The very first quasar they studied in detail, it's called 3C273, turned out to be shining 100 times more brightly than the most brilliant galaxies in the entire universe. Think about that. But believe it or not, that wasn't even the most shocking part. Nope, the real shocker was its size. All of that insane energy, all that light, was pouring out of a region of space that was at least 1,000,000 times smaller than a normal galaxy. It was just an unbelievable, impossible concentration of power. So that was the big question that had every astrophysicist scratching their head. What in the world, what kind of engine, could possibly be so tiny and yet so mind-bogglingly powerful?
And this is where it all comes together. This is where that theoretical monster, the thing Einstein hated, became the only possible answer to this huge cosmic mystery. His outrageous legacy was about to roar to life.
Okay, so scientists crunched the numbers. They looked at the most powerful engine they knew of, nuclear fusion, the thing that powers our sun, and it just wasn't enough, not even close. To power one of these quasars, you would need to burn through billions of suns worth of fuel with perfect efficiency. Just impossible. So after ruling everything else out, there was only one engine left in the universe powerful enough to do the job. The pure, raw energy of gravity itself, unleashed by the very thing Einstein refused to believe in.
So what is this thing really? Well, physicists came up with this amazing idea called the no-hair conjecture. The idea is that when a giant star collapses, all of its messy, complex details, they call it hair, get blasted away into space. And what's left behind is this object of perfect, terrifying simplicity. You can describe it completely with just 3 numbers. Its mass, its spin, and its charge. That's it.
And so finally, in 1967, the physicist John Wheeler gave Einstein's rejected singularity a proper name. A name that finally stuck, one that was just as simple and powerful as the object itself: the black hole.
The evidence was all pointing in one direction for sure. But the ultimate proof, the absolute smoking gun, that wouldn't arrive until a century after Einstein first came up with his theory. It came when we finally figured out how to listen to the echoes of space-time itself.
You see, another prediction from Einstein's theory was that huge, cataclysmic events, like 2 massive things crashing into each other, would send out ripples through the very fabric of space-time. They're called gravitational waves, and you can basically think of them as the sound of the universe shaking. And then, in 2015, it happened. We finally detected them. And the signal we picked up told the most incredible story. It was the story of 2 massive black holes, each one dozens of times heavier than our sun, spiraling into each other at almost the speed of light. They were violently warping space-time all around them, before finally crashing together and merging into one. The energy released was, well, it's almost impossible to imagine.
In just a fraction of a second, an amount of mass equal to 4 of our suns
Wasn't just destroyed, it was converted directly into pure gravitational wave energy. It literally shook the universe with more power than all the stars in the entire observable cosmos shining at once. Just wow. Einstein's most outrageous, unbelievable legacy was finally confirmed in the most dramatic way possible.
So think about that. The man himself refused to believe in them. And yet, it turns out black holes are the engines that power the brightest objects we can see, and their collisions create the loudest sounds we can possibly hear. Which, of course, leaves us with one final tantalizing question. If Einstein's legacy revealed this, what else is still hiding out there in the warps of space-time?